First set of pumping is going to be bicopharyngeal pumping. This pumping action of the mouth and pharyngeal region that creates positive pressure across the gills for respiration. Repeat the B pumping one. So bicopharyngeal pumping is the one that is the action of pumping of the mouth and the pharyngeal region that creates positive pressure across the gills for respiration. So this is the one that does not happen when you move. Unlike ram ventilation, this is going to be a method of creating a respiratory current by swimming with the mouth open, allowing water to flow over the gills. So that one is what sharks do. They have to keep moving. Now, a gas bladder is a sac within a fish that contains gas, adding in buoyancy, regulation, and depth control. We have two different ways of doing it. Schizoautomosis is the way a type of fish with a concentrated connection between gas bladder and intestine, allowing for regulation of gas volume by adding or removing gas through the esophagus. Repeat the one that has ostomosis. So phiostomosis is a fish that connects the gas bladder to the intestine, and then it regulates the gas through the esophagus. So the phiostomosis is going to be the fish that has gas bladder and intestine, allowing for regulation of gas volume by adding or removing gas through the esophagus. Now this is going to be different than our Psioclitoris. So our Psioclitoris, or clitus, is going to be the fish that can increase the volume of gas bladder by secreting gas and blood, and decreasing volume by absorbing gas from the bladder, adding it to their buoyancy control. So, the one that is Phycoclitus is going to be the one that has a gas bladder secreting gas from the blood. So the osmosis is solely with the intestine, whereas this one is going to be with the blood, if that makes sense. Now, hearing in fish without gas bladders is interesting. It's sound that travels through the tissue of the skin and the skull to reach the inner ear, enabling the fish to perceive the auditory stimulation without the aid of gas bladders. So just kind of, they just feel it. Now, hearing with gas bladders, sound travels through the tissue to the gas bladder, which then vibrates to transmit the sound to the inner ear, facilitating auditory perception with fish with gas bladder. So it just goes to the gas bladder and so straight to the ear if they have one. That's the only big difference. Now we have passive electroreception. This is the ability of fish to detect weak electrical fields gathered by muscle contraction of quadruped, aiding in the location and capturing of food. So that one's just passive, they just automatically hear it. Whereas active electroreception is going to be the ability of some fish possessing electric organs that generate electrical discharge, which are used for navigation, communication, and prey detection. Pretty basic stuff. Then maintaining body temperature in fish. They regulate their body temperature as part of maintaining an internal environment, with some species capable of limited thermal regulation. It's like tuna can do that, but not all species. Nitrogenous waste in fish. This is when a fish excretes nitrogenous waste as part of maintaining as an internal environment, with primary forms being ammonia and urea, depending on the species and environment. The ammontili is going to be the excretion of ammonia through skin and gills and urine produced by the kidneys, requiring no metabolic energy and serving as a primary method of nitrogenous waste excretion in many fish. So the ammonidity, remember ammonidity, ammonotili, that one, I'm saying enough, ammonotili is going to be the passive one that goes through the skin, gills, urine produced by the kidneys with no metabolic energy, and serving as a primary method of nitrogenous waste for many fish. Now, our urality is going to be the synthesized urea from ammonia in the liver, requiring more energy but produce less toxic substance that can be concentrated in urine, serving as the alternative method to nitrogenous waste. So just remember this one, if it has a UREO, it's going to cost stuff. Now if we're on osmoregulation in fish, this is going to be the process by which fish maintain both water and salt balance to prevent fluids from becoming too concentrated or too dilute, and this is just needed. All cells need that. Just remember the osmoregulation. Also more, that's kind of like the kidney area. I talked about that earlier. Just remember that, as anytime that has something to do with balance, like salt and that, osmore, just remember balance and stuff like that.